Hi guys, so in this video we're going to talk about the 3 different types of muscle tissue and just learn a little bit about them each. So the skeletal muscle tissue, it kind of looks like a bundle of sticks, basically, if you put all the skeletal muscle cells together. Kind of looks like that. It's like cylindrical, and they are also multinucleated, so you're going to see dots all the way throughout. You can think about it kind of like a flute maybe, but they're stacked one on top of the other, kind of like this. So you would have more of these going end to end, like all the way down, and then they would also have their own multiple nuclei. And then they also have striations or stripes. They have a particular banding appearance. So sometimes you might see it look like this kind of in the pictures. Okay. All of the stripes go parallel to one another, better than what I'm doing here with my mouse. Okay. Now, the cardiac muscle cells, these are going to look a little bit different. They only have one nucleus, but they do also have the stripes, and then they are branching. Okay. And so if this were just one cell here, whoops, one cell, it would have a branch in it like this, and it's only going to have one nucleus kind of in the middle. So where it would meet up with another cell might look like, this and be branching this way. They're not all, kind of Y-shaped. It's just that's the easiest to draw. They do also have striations, and these all go parallel with whichever direction the branch is moving. So these are going to be the stripes in the cardiac muscle cell. Now, these junctions in between the cardiac muscle cells, these are what are called intercalated discs. Okay. It's a special junction between cardiac muscle cells. It's a tight junction, and that is so the cells closely are connected and can communicate with one another, because a special property of cardiac muscle tissue is that it beats all on its own. It contracts all on its own. Even if you have a single heart muscle cell in a petri dish, not connected to a brain and not in the body, as long as it has enough of the cell signaling molecules, which is going to be calcium, and it has enough oxygen and sugar, it's going to beat all in time. And if you have 2 cardiac muscle cells and they're not connected, they're going to beat at their own pace. But once they connect together via these intercalated discs, if you have 2 in a petri dish and you put them close together, over time they're going to form this intercalated disc, and then they're going to beat in unison. They'll synchronize with one another, which is just really, really cool. So a heart can actually beat all on its own, not connected to a brain, doesn't need any extra input, as long as it has enough fuel to be able to do so. Now the smooth muscle looks a little bit different than both of these. It looks, we call it spindle shaped, kind of like a candle flame. Oops, I switched over to black. Okay, and then each one is going to have a nucleus all on its own. Okay, and these are all connected with one another. You could think of it like, I don't know, a lot of like eyes looking at you. Okay, there you go. Okay, and that's smooth muscle. It doesn't have any stripes, but there's only one nucleus per cell. Okay, now these, if I were to make a table then, so if we have nucleus going along this way, and then we have striations, and then, well, I've already talked about the shape, I guess, so I'll delete that one. But if we look at it just this way, all right, the striations, you're going to have a check mark here. Yes, we have striations. Yes, we have striations. No striations here. And a number of nuclei is plural. It's going to have more than one. Only one and only one here. Okay. And then these are found in particular places only. So cardiac muscle cells are only found in the heart, and that is it. You're not going to find them anywhere else in the body. If you do, something went wrong with that body. Smooth muscle, these are found lining the hollow organs. And so with the exception of the heart muscle, although there is a little bit of smooth muscle in there actually, so I guess that's not an exception. So you have smooth muscle in all of your ducts in the body, like attached to glands. It'll be in all of your arteries and veins. It's also going to be in your esophagus, your stomach, your small intestine, your large intestine, your urinary bladder, your gallbladder. Basically, any of the big organs that you could pull out and there's open space in it, then you will find smooth muscle there. Smooth muscle is for transporting substances through those organs. Cardiac muscle is for pumping blood through the heart. And then skeletal muscle, you're going to find this one attached to bones. And it's for movement of the whole human being. Okay, skeletal muscle has to be attached to bones, typically in at least 2 places. Sometimes there's a little bit more, and there's a few muscles that don't attach to any bones, but those are more rare. But the skeletal muscle will shorten all at once and pull on a bone, and then that's what moves your body around using a lever system, basically. And that's it for muscle tissue, short and sweet and to the point.